Yeah, yesterday we have seen threshold frequency. Threshold frequency. It is being shown by nu zero. The minimum frequency at which the phenomenon of photoelectric effects just starts, or emission of photoelectron just starts, photon just starts, is called as threshold frequency. Is called as threshold frequency. Now we have seen the characteristics of the threshold frequency yesterday. At threshold frequency, the energy of the incident beam just equal to the binding energy, the work function of the metal cathode surface. Second thing, at threshold frequency, the emission just starts. Below threshold frequency, no emission of photons. Above threshold frequency, the emission will continue. But we know right now, C is equal to nu lambda. C is equal to nu lambda, or nu is equal to C by lambda. That is, frequency is inverse to the wavelength. Now, corresponding wavelength with respect to the threshold frequency will be called as threshold wavelength. Threshold wavelength is being shown by lambda 0. The wavelength corresponding to the threshold frequency is called as threshold wavelength. The wavelength corresponding to the threshold frequency is called as threshold wavelength. Now, since from this equation, frequency and the wavelength are inverse to each other, that means the minimum frequency, that means the maximum wavelength, So, the definition will be the maximum wavelength at which emission of photon just starts is called as threshold wavelength. Lambda 0. Now look here, if I take this as a maximum wavelength, if I increase the wavelength, then frequency reduces, then the frequency will get down below the threshold frequency, then the emission will get stopped. So, if I decrease the wavelength, then the frequency will increase above threshold frequency. That is why I have written here the maximum wavelength. Below threshold wavelength, the emission will continue. Above threshold wavelength, the emission will get stopped. Now look here, these are the two different statements. Below threshold frequency, if I put here threshold frequency and threshold wavelength, this is below threshold frequency. No emission. Above threshold frequency, emission continue. Now this is threshold wavelength. Below threshold wavelength, emission continues. Continue. Above threshold wavelength, no emission. This is the because frequency and the wavelength are inversely proportional. That is why this is the minimum frequency at which photoelectron starts, and above threshold frequency will continue. This is the threshold wavelength, maximum wavelength up to which the emission will be there, and below that will continue, and above threshold wavelength no emission will be there. No emission will be there. So this you must have to understood. What is the relation between them? This is the relation, and due to that relationship you have to understood this concept. And this is very important concept, because many numericals are being there in which they determine, they want to understood whether the student have got the concept or not. Then you have to put forth that above threshold wavelength no emission, below threshold wavelength emission. Above threshold frequency emission will be there, below threshold frequency no emission will be there. No emission will be there. This you must have to understood. This you must have to understood. Now next one. Now, corresponding to threshold frequency, the energy of light radiation, E is equal to h nu 0. E is equal to h nu 0, or if I put here nu is equal to c by lambda, then it becomes equal to hc upon lambda 0, because this is the energy corresponding to the incident radiation at the threshold frequency. Now henceforth onwards, this E will be defined by W, that is called as work function. So work function is equal to h nu 0 or hc upon lambda 0. Now at this frequency, threshold frequency, the emission just starts. So energy of incident radiation is equal to binding energy of cathode surface. So henceforth onwards, it will be called as W0 is equal to hc upon lambda 0 or h nu 0. Now unit of energy is in SI system. It is joule. But henceforth onwards, we will be using a smaller unit of energy, that is called as electron volt. When an electron is accelerated through a potential of 1 volt, the energy acquired is called as electron volt. So 1 electron volt is equal to 1.6 into 10 raised to minus 19 joules. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. This is the energy requirement that is being used, unit that is being used while calculating these values there. Now write down it. In general, above threshold frequency energy of light radiation is given by W is equal to hc upon lambda or h nu, where nu is equal to incident radiation frequency or frequency of incident radiation, or wavelength is the wavelength of the incident radiation, and lambda is equal to wavelength of incident radiations. Wavelength of the incident radiation. In this way, this is very small definitions which is very important with respect to the numericals that you have to write and that you have to understood.